Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today, we're exploring how stars are born and die, and how their lives shape the very fabric of the cosmos. Every story in the universe begins in darkness. In the cold depths of space, where vast clouds of gas and dust drift silently, something extraordinary begins to stir. These immense regions, called nebulae, are the wombs of the stars. Though they seem empty from afar, inside them lies enough material to build thousands of suns. Within these clouds, gravity slowly starts to pull hydrogen and helium atoms together, gathering the scattered pieces of the universe into tighter and tighter knots. As the material collapses inward, it begins to spin. Like a cosmic whirlpool, the cloud flattens into a disk with a dense clump forming at its center. Friction and compression heat this core until it glows faintly, the first light of a newborn protostar. For millions of years, this infant star continues to feed on the surrounding gas, growing heavier and hotter until, deep inside its core, something remarkable happens. The pressure and temperature reach a critical point, about 10 million degrees Celsius. At that moment, nuclear fusion ignites. Fusion is the engine of the stars, the process that turns ordinary hydrogen into helium, releasing vast amounts of energy in the form of light and heat. It's the same process that powers our own sun. When fusion begins, a delicate balance forms. Gravity pulls everything inward, trying to crush the star, while the outward pressure from fusion pushes against it. When these two forces equalize, the star settles into the longest and most stable period of its life, the main sequence. During this stage, a star can shine for billions of years. Small stars like red dwarfs sip their fuel slowly, glowing dimly but enduring for hundreds of billions of years, longer than the current age of the universe itself. Larger stars, however, live fast and die young. The more massive a star is, the hotter it burns and the faster it consumes its hydrogen. Our Sun, a medium-sized star, has been on the main sequence for about 4.6 billion years and still has another 5 billion years or so left to burn. As the hydrogen in the core begins to run out, the star's life starts to change. Without enough fuel to support the outward pressure, gravity begins to win. The core contracts and heats up, while the outer layers expand dramatically. The star swells into a red giant, a bloated, glowing sphere that can engulf nearby planets. For our Sun, that means one day, billions of years from now, it will expand enough to consume Mercury and Venus, and perhaps scorch the Earth's orbit. Inside the red giant, new reactions begin. The intense heat allows helium atoms to fuse into carbon and oxygen, creating heavier elements, but the end is near. When the helium runs out, the outer layers of the star drift away into space, forming a delicate shell of glowing gas known as a planetary nebula. At the center, what remains is a small, dense core, a white dwarf, roughly the size of Earth but with the mass of the Sun. It no longer produces energy, but it glows faintly for billions of years as it slowly cools. For stars much larger than the Sun, the story is far more dramatic. Their immense gravity drives fusion through heavier and heavier elements, carbon, oxygen, neon, silicon, each layer burning hotter and faster than the last. In a massive star, the core becomes a layered structure, almost like an onion, with different fusion processes occurring in each shell. Eventually, the fusion creates iron at the center, and that's where the process stops. Iron cannot release energy through fusion. Instead, it absorbs it. The balance that kept the star stable collapses in an instant. When that happens, gravity takes over completely. The core collapses inward at nearly the speed of light, and the outer layers crash down upon it. The result is one of the most violent events in the universe, a supernova. In that split second, the star's outer material is blasted into space at incredible speed, shining brighter than entire galaxies for a brief moment. The energy released in a supernova is almost unimaginable. It's in this cosmic explosion that new elements are created: gold, silver, uranium, and many others. The atoms in your body, the iron in your blood, the calcium in your bones, the oxygen you breathe, were all forged in stars that lived and died billions of years ago. You are literally made of stardust. What happens to the core of a massive star after a supernova depends on how heavy it is. If it's about 1.5 to 3 times the mass of the Sun, it becomes a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Neutron stars spin rapidly, some flashing beams of radiation like cosmic lighthouses, which we see as pulsars. But if the remaining core is even more massive, gravity overwhelms everything, and the core collapses into a black hole, a region of space so dense that not even light can escape. Though the death of a star might seem like an ending, it's really a new beginning. The debris from supernova explosions drifts through space, mixing with gas and dust to form new nebulae. From these enriched clouds, new stars are born, this time containing heavier elements that allow planets, chemistry, and eventually life to exist. In this way, stars are not just the engines of light in the universe, they are the creators of everything we know. The cycle of stellar birth and death is the heartbeat of the cosmos, a grand story of transformation that connects us all to the stars above. When we look up at the night sky, we're seeing this story unfold across time. Some of the light reaching our eyes tonight began its journey thousands or even millions of years ago, long before humans existed. Each point of light is a chapter in the universe's long narrative, a story of gravity, energy, and time. The stars we see are not eternal. They are fleeting moments in cosmic history, burning briefly and beautifully before passing their light to the next generation. Our own sun is one of countless billions, but its fate will be gentle compared to the giants of the galaxy. When it finally becomes a white dwarf, the outer layers it sheds will drift away, perhaps forming new systems and new worlds. The atoms that once made up our planet and our bodies will be carried into the next cycle of creation. In that sense, nothing in the universe is ever truly lost. It all transforms, from light to matter, from life to dust, and from dust to stars again. The life of a star reminds us of something profound. Creation and destruction are two sides of the same cosmic process. Stars illuminate the darkness, forge the elements, and give rise to everything from the simplest atom to the most complex living being. And in their deaths, they scatter the seeds for new beginnings. Every star that dies makes the universe richer, more diverse, and more alive. This endless cycle of birth and death is what keeps the cosmos in motion. From the quiet murmur of hydrogen atoms in a nebula to the blinding brilliance of a supernova, the life of a star is a story of balance between gravity and energy, chaos and order, beginning and end. It is a reminder that even the mightiest forces in the universe are part of a larger harmony. So the next time you look up at the night sky, remember, you're not just looking at stars, you're looking at your origins. Every atom of your body has been through the heart of a star, transformed by fusion and scattered across the cosmos. The universe is not out there, it's within you. This is Mattermosaic, piecing together the universe, one discovery at a time. If you enjoyed this exploration, let us know in the comments and keep the journey going by watching our next video.